Hey everyone. So these days, machine learning is quite in trend, and everyone wants to learn machine learning. But most people learning machine learning make the exact same mistake. Even I, in my first or second year of college, I also made the same mistake. You know, people just install scikit-learn, maybe TensorFlow, copy the same tutorial code or the code given by ChatGPT, train your model, and get a 95% accuracy. Wow, it feels good, yeah, that yes, I am getting so much accuracy. Wow, I know machine learning. But then if someone asks, what exactly is gradient descent? How is overfitting happen? Or what is overfitting? Then how PCA actually work in this? Then how can you optimize it even further? And that's where everything falls apart. So I have decided that let's learn machine learning from its base and in a bit different way. So, the wrong way. What most people actually do these days is they learn Python, then they install TensorFlow or scikit-learn library, and then they fit their model. I mean, copying the code and just fitting everything, and they get the accuracy of 95%. And then they get confused. Oh my God, how I've got such high accuracy? I mean, they don't know how has this accuracy come? How can I increase it? I mean, on all that. So this is how most people do. And to be clear, building projects early is not bad. In fact, practical work is important. But if you only learn tools, you never understand the underlying concepts. You become someone who can run code, but not someone who truly understands what machine learning actually is. So what ML actually is? In ML, we have three basic boxes. One is the data, one is the algorithm, and the third one is learning. Algorithm, or you can also say that the model. So, if I ask myself what actually is machine learning, at its core, we have these three things: the data, the model, and learning. So, let's say you want to predict house prices, the most basic example that anyone gives you when you start learning machine learning. So, if I take this house example and try to fit these three things, the like even if you ask any stranger, he will also reply in this way only. First, I'll see what data I have, the previous house records, the previous data of the houses. Then a model, which is nothing but a mathematical function trying to match the inputs. Suppose if you are staying in a place where the house price doubles every year, so your mathematical model becomes y equals 2x, right? But it does not happen, and there are a lot of uncertainties in our society. Then suppose if there's a graveyard beside your society, the prices actually drop, right? And that's when learning happens. What all changes are taking place, and learning those changes, and then also predicting, adjusting the model so that predictions are not hampered. That's what learning actually is. And that's the core idea of machine learning. So, what's the real issue? And here's where beginners, including me, went wrong. We mistake memorization for understanding. Just because the model performs well on trained data doesn't mean it actually learned something. Maybe it just memorized patterns. Real machine learning is about generalization. Performing well on data the model has never seen before. And to understand why that works, you need foundations. So, there are two interesting paths that one can follow in their machine learning journey. One is the top-down approach, in which you build projects, libraries, and then go to concepts. Okay, so you first build projects, then know what libraries are used, as like when you keep on building projects, you know what libraries have been used, and then you go to the concepts. And next is the bottom-up approach, in which you first do the math, then you do the theory, and then you build the applications. And this is where I found a really interesting idea. There are basically, like, uh, I mean, basically, these are the two paths any machine learning enthusiast follows. So, top down and build first, learn concepts later. This is fast, feels exciting, but foundations can be weak. Next, the bottom up. Learn the fundamentals first. You have linear algebra, probability, calculus, optimizations, and then build upwards. Just slower, but gives you much deeper understanding of the subject. And honestly, most people probably need a habit of both in this upcoming generation of AI. So, what's the roadmap? So, like a proper roadmap, if I say, you have to do linear algebra, most basic and most important part of machine learning. Do some geometry, then matrix, calculus. Uh, then apart from that, you have probability and statistics. Then optimizations. So these are all the math part that one must know before starting machine learning. And after you know this, you can get to regression, then classification, then dimensionality reduction, then deep learning, reinforcement learning, and so on and so forth. So this made me realize that machine learning isn't just random. It's a structured roadmap. You can't deeply understand gradient descent without calculus. You can't understand PCA without linear algebra. You can't understand probabilistic models without probability. And everything connects at the end. So I've decided to do something different. I'm going to learn machine learning from its first principles, and that too properly, from beginner to advanced level, and document the entire journey publicly, because it's the age of learning in public. And not, I won't act some fake guru, not pretending that I know everything, but as someone genuinely interesting in this field. So right now I'm reading mathematics for machine learning, and each time I learn something worth explaining, I'll make a video. So if you are someone trying to actually understand AI and machine learning, not just copy code, maybe join me. Next video, most probably, uh, we'll be talking about vectors, because as I told you that linear algebra, the foundation of machine learning. So in that, the most important thing is vectors. So we'll talk about that in the next video. Bye.